AII commissioned this study on low carbon thermal energy that has been authored by Global Efficiency Intelligence to really align the industry on how it can move forward on the topic of low carbon thermal energy. As many of you will know, the thermal demand of the sector is very high, and where that energy comes from represents one of the kind of key sources of emissions and therefore a key opportunity for reduction. And within AII and our climate solutions portfolio, this is then, of course, a big focus for us to help the sector move forward on this topic to implement solutions. And we found that commissioning this roadmap was a key step towards that, so that we had all of the information available to make that implementation happen. So this first work package is really setting the foundational knowledge on those key technologies, and that's what the team will be speaking to you about today. And then that next report really goes into detailed recommendations for specific countries, so India, Bangladesh, China, Vietnam, and Indonesia, giving the roadmap between now and those important milestone targets. What is feasible, what should happen. And it's really those recommendations that will inform how AII moves forward in supporting brands and suppliers to achieve their Scope 3 reduction targets, focusing on this topic going forward. So yeah, we're very excited to share this report with you today, and also incredibly looking forward to the implementation work that will come out of it. So over to you, Ali.
Great. Thanks, Pauline. So with that background, let's discuss the content of this report. So we are going to very briefly talk about the scope and also fairly briefly about some of the barriers and the drivers for low carbon thermal energy for textile industry. In this report, we cover 6 what we call alternative low carbon energy sources and technologies. Energy sources like biomass, solar thermal, natural gas, and technologies, for example, electrification technologies. We looked at 3 electrification technologies: electric boilers, industrial heat pump, mainly what we mean is high temperature steam generating heat pump, and also thermal energy storage, basically heat batteries. So these 6 technologies are included in the assessment. Of course, natural gas is not really low carbon, but compared to coal, if the methane emission is managed well, could be lower carbon. So there are some, nuances that we will get into. We have a technology comparison matrix that we will present later, and comparing all these technologies with respect to certain indicators and pros and cons of this and how they rank across those indicators, and a very brief recommendation. Hopefully we won't run out of time. Just briefly, I already introduced Global Efficiency Intelligence, but also just to let you know, we did launch a platform called Textile Sustainability Hub, like some 5 years ago. It is meant to be a platform where we research and share information on decarbonization of textile industry, similar content like what we published today. So if you're interested, please check that website. You will find much more information, publications, and tools for decarbonizing textile industry. Also, on the topic of electrification, we launched a platform last year, Industrial Electrification Center. If you're interested in that topic, also, you will find a lot of useful information there from the work we have been doing, and also we are going to share work others have been doing on industrial electrification. As I said, we do have textile engineering background, and we have done a fair amount of work on textile industry decarbonization. The last work we did that was published was electrification of heating in textile industry. In the past couple of years, actually, we have been working with a number of brands. Some of you are here already, and their suppliers mainly in Southeast Asia and East Asia and South Asia. And we have been conducting pre-feasibility analysis for deep decarbonization or electrification of heating in some of these facilities. So facility level feasibility studies we have been conducting. Some of those works, because they're at the facility level, they are not published yet. On the topic of electrification, which are half of the technologies we are discussing, we have been doing a lot of work, especially in the past 6 years or so, and the work we have been doing covers a range of industries across many different industries, not only textile industry, so we can really tap into all the diverse knowledge we gain there, and also across different countries. I start with US, then we did work on China. As we speak, we are finalizing and hopefully publish reports on Europe and India on electrification of heating in those countries. But back to textile, I think for this group, I don't need to mention already, textile industry accounts for about 2%. Some estimates say a bit higher, depending on where you draw the boundary of global GHG emissions. So as you know, we use electricity in textile plant and heat. When we look at the textile industry, often we look at the typical, when we call it typical plant, the plants that do have wet processing. So we are not talking about just, the simpler plant that's just doing the sewing. So textile manufacturing, where fair amount of heat is consumed. So on the electricity side, if the suppliers or a textile plant located in countries where renewable procurement for corporates are available through power purchase agreement and other mechanisms, then decarbonizing electricity is, I would say, a low-hanging fruit. Unfortunately, in many geographies, including in Asia, that's happening. If you go to China and India, in many locations there would not be a problem having corporate renewable procurement now. And a lot of these are happening in recent years, but still, I was in India a couple of weeks ago, and I was pleasantly surprised how vibrant and advanced now is the corporate renewable procurement market there. So, but then we have countries that's not the case. For example, Bangladesh, some of the countries in Southeast Asia, and there is more work to be done there. But if the renewable supply is there, the electricity is rather straightforward and low-hanging fruit. But the heat is the elephant in the room that we need to decarbonize, and everybody is scratching their head. So that's the focus of this study and the next report that's going. We are looking into how to decarbonize heating in textile industry. Significant amount of heat is used, often for steam generation. Some part of it is also in hot oil boiler that is used in some of the processes. So we are looking into all that. Fortunately, textile industry is what we call a low temperature industry, because as I mentioned, we are doing work across different industry sectors compared to, let's say, steel, cement, chemical, where you have all this like high temperature processes. In textile industry, all the processes, almost all of them, they require temperature below 200 degrees C, and many of them below 100 degrees C. Steam is used in many of these, in some cases, hot oil. But overall, relatively speaking, when you have these lower temperatures, you have, relatively speaking, compared to high temperature, it's easier to decarbonize or electrify or use, all these other technological options that we have. So that is something to keep in mind. So that's a good news. So stepping back, just to kind of frame the scope of this, anything you do to decarbonize the industry sector, any industry, falls under 5 major decarbonization levers or pillars. First one is material efficiency and circular economy and everything related to that. You're all familiar with. Energy efficiency is the second one, pretty straightforward. Third one is electrification of heating through electric boiler, heat pump, thermal storage, which we are going to get into that in detail. The fourth pillar is what we call low carbon fuel, feedstock, and energy sources. In the context of textile industry, consider, for example, sustainable biomass, solar, thermal, etc. And the fifth pillar that is not really applicable to textile industry, that's why it's not shown as a separate column, is the CCUS. And because of the nature of emission from textile plant, you really can't apply carbon capture there. So in this report, the technologies we are covering, they fall under electrification, 3 technology, and they're under low carbon fuels, which are sustainable biomass, solar, thermal, and natural gas. So these are the 6 technology under these 2 pillars. We are not saying other pillars are not important. Definitely you should do energy efficiency. Definitely you should do circular economy. But to get to net zero, you do need these technologies we are discussing today, at least some of them, the ones that are actually can be implemented and can be impactful. Energy efficiency cannot get you to net zero. Circular economy definitely is on the demand side and needs to be implemented. It has its own challenges. Many people are working on it. But in this report, we focus on these 2 pillars. So one other thing to mention, because 2 of the these alternative technologies or energy sources we are discussing are rather controversial, have nuances. Let's start with natural gas. natural gas, if you combust, the emission from combustion is lower than coal. Coal, usually you get emission around 92, 94, 96, depending on type of coal. Natural gas, you get 50 or 55 or 56. So you have higher emission. However, as you all know, there is a massive now backlash toward natural gas because of this upstream methane emission. And because methane has significantly higher global warming potential, it can result into natural gas having actually higher CO2 emission equivalent per gigajoule of energy than coal. And actually, it's a pretty serious issue that cannot be ignored. Next, biomass. If it's sustainable, carbon neutrality can be assumed. So basically, almost zero emission. However, if you consider unsustainable biomass, then it is simply worse than coal in terms of CO2 emission. So one of the takeaway from this webinar should be that biomass, unsustainable biomass, is definitely worse than coal and should be avoided at all cost. Simply go to IPCC greenhouse gas inventory. There's a table there, there's a guideline, there's a table there, and look at the CO2 emission factor of the fuels. Biomass, almost all of them are having higher CO2 emission factor than coal. Actually, many of them are above 100. So not only that, burning biomass will emit more CO2 emission than coal, it has all the damages to the ecosystem, biodiversity, and food versus fuel, etc. If it is unsustainable. We are not saying all biomass is bad. Sustainable biomass from sustainable agricultural waste is fine. So that's another thing to keep in mind. Of course, solar thermal, it's just a solar energy, so no emission associated with that. So very quickly, we have a quick look at some of the barriers and drivers when we talk about low carbon thermal energy technologies for the textile industry. First, with the barriers, I don't get into detail, but from what we have seen and all the work we are doing firsthand with brands and suppliers and textile companies, there is definitely a lack of knowledge and need for education and capacity building with regards to some of the technologies, for example, electrification. People simply are not aware of this. The cost of some of these technologies are high, the capital cost, not for all of them, for some of them. The financing of it is a challenge. Textile industry, mostly they are SMEs, and even for medium size, having access to financing is a challenge, especially in developing countries. There is limited supply of some of these alternative, energy sources. For example, sustainable biomass is limited. Natural gas, many of the textile producing countries don't have it, assuming natural gas is a reasonable option. Policy and regulatory environment in some of the countries are not favorable. For example, having policies that allows for PPA, corporate renewable procurement, and those kind of things. The grid is not clean in some of these countries or many of these countries in Asia, and that is a barrier for example, electrification. And the fact that the equipments are in place, there's a sunk cost, and replacing those, that means you're depreciating the existing equipment, and that has cost implications. So these are some of the key barriers, kind of a snapshot of that. However, there are also drivers. What's driving? And we see things are happening slowly. Some of you already, if some of the brands on the call, I'm sure you are working on it already. The climate policy, both at the country level and company level, we have all these net zero targets and we have the drive, some countries more, some countries less. But already there is this push from the highest level to decarbonize. The energy costs, renewable energy costs dropping, some of these technologies costs are dropping, and that is a good news. So some of the things we are hearing, it's like what was there from 5 years ago. Things are really changing. Technological readiness. Again, when we talk about thermal energy storage, electrification technologies, they're like 10 years ago, a steam generating heat pump, it was really nascent. But now, as we speak, they are implementing them. So they are available. We have been talking to steam generating heat pump manufacturers. Just 2 days ago, I talked to one in India, a startup in India manufacturing a steam generating heat pump. And of course, in US, Europe, Japan, and other markets, there are many of them. There is energy security aspect. We saw what happened, with the Russian invasion of Ukraine, what happened in Europe, also in India and China, huge concerned about energy security, and they have local renewable, so that's a drive itself, and other aspect that I don't need to get into detail. So I think I already mentioned this. What we are covering, we are going to go through every single of these alternative low carbon thermal energy technologies and give you a snapshot of each technology and also the assessment we have done for 20 major textile producing countries in terms of ranking them with regards to the readiness that they have for each of these technologies. Biomass, solar thermal, electrification technologies, 3 of them, electric boiler, industrial heat pump, thermal storage, and natural gas. And with that, I would like to turn it to my colleague, Cecilia, to talk about biomass. Cecilia?
Great, thanks, Ali. Next slide, please. So the first of the 6 low carbon energy sources and technologies that we evaluated was biomass, looking at biomass use in boilers. And biomass-fired boilers are capable of providing low and medium temperature steam for the textile industry. It's an established technology, and it's also increasingly been a fuel source of interest for the textile industry with rapid adoption in many places in the last few years. Biomass includes the categories of energy crops, waste biomass, agricultural residues, and forestry products. And here we're largely focusing on agricultural residues as the biomass source with the largest potential for sustainable sourcing. And so Ali mentioned earlier that biomass has a higher emissions factor than coal when combusted. And so carbon neutral biomass refers to biomass that sequesters as much carbon as it releases during the combustion process and does not harm local ecosystems. So when we talk about sustainable biomass, which our evaluation is focused on, we're looking at sustainable biomass that has been sourced with a lot of these considerations in mind and is carbon neutral. And this is highly dependent on the local context and how the biomass is produced, transported, and processed. Next slide, please. So for each of the 6 energy sources and technologies, we analyzed their strengths and opportunities, their challenges, the available supply and infrastructure, as well as the cost. And so as we go through this presentation, you'll see this same diagram for each of the 6 technologies and energy sources. And so for biomass, I mentioned some of the strengths and opportunities, that it's a mature technology, it can take advantage of existing waste, and it has the potential for carbon neutrality. However, the biggest challenge that we want to highlight here is that it's highly dependent on whether or not biomass can be sourced from sustainable origins. And there are many challenges in doing so, including competition with other uses of land, as well as, especially if it's associated with land use change. There is scientific debate about carbon neutrality of different sources of biomass. And so in general, it's a very area for a high amount of caution. There are also other challenges with regards to an individual textile facility being able to handle diverse potential feedstocks. There may be complex logistics for transport and storage, and fuel costs are highly dependent on local supply, as well as the higher capital cost of biomass boilers relative to coal boilers. Next slide, please. So for each of the 6 energy sources and technologies, we also did a country readiness assessment, looking at the 20 major textile producing countries around the world and assessing each energy source or technology on a number of different indicators. And we then use these indicators to create a ranking and a scoring system. And we sorted the countries, each of the 20 countries, into buckets of being most ready to adopt the given energy source or technology, moderately ready, or less ready without support. And this is regarding adoption in the near term, And countries that are less ready would require a longer time frame or more support in order to be able to adopt those technologies for heating in the textile industry. So when it came to evaluating sustainable biomass in particular, we looked at country readiness in terms of a couple of metrics. These include the availability of biomass supply chains and infrastructure, the share of biofuels and waste in their total energy supply in a country as a proxy of availability. We also looked at a metric on agricultural production of crops that their residues are typically used for biomass in each country, and several other metrics. And so based on these indicators, as I mentioned, we created this composite score, and it's a combination of quantitative and qualitative assessment. And so most potentially ready for biomass adoption here, we've listed are China, India, Thailand, Turkey, and the US. It's important to note that we're not necessarily recommending that biomass adoption happen, but that some of the factors may be in place to explore sustainable biomass in these countries, especially relative to other countries. So before moving on to the next technology, I'll pause and see if Ali wants to add anything about the biomass.
Thanks, Cecilia. Just a quick, for example, some of you who are familiar, you see Vietnam as moderate and Sri Lanka as less ready, and you might be surprised. Again, we are not ranking based on availability of biomass or what's happening, especially, for example, for Vietnam and Sri Lanka, already too much biomass is happening. Based on our assessment, we are not recommending any more biomass there. It's just already a good portion of it are unsustainable as well. So this is not saying there is biomass and you should go use it. This is assessing based on different criteria and saying some of the places where, with all the consideration, there could be some sustainable biomass exploration that is there. But some of the countries already with high use of biomass may not rank well because it's already too much there, and we think limited additional potential is there. If you're a apparel brand and your supplier comes and basically say they have switched to biomass, basically it's more of a bad news than a good news. Based on everything we are learning from industry in Southeast Asia and South Asia, in textile industry, there is good amount of unsustainable biomass being used. And even if your suppliers, through some of the verification method and standard, say that they are using sustainable biomass, they are taking sustainable biomass from the limited supply. So somebody is going to go after the unsustainable biomass. Unfortunately, some large apparel brands, they set in place a very aggressive target for coal phase out, and then they went to the Asian countries and pushed them towards biomass. And then that gave a very inappropriate signal to the textile industry in those countries that biomass is the solution. And then if you go to some of these countries, for example, Vietnam, every single textile producer is switching to biomass. Where is all this biomass coming from? So we basically say you have to be extremely cautious, and you have to be also more even careful with your messaging, even if your supplier biomass is verifiably sustainable. So that's my additional remark.
Great. So the next technology that we all evaluated was solar thermal technology. Next slide, please. And so here we give a brief description of the technology. There are two main technologies to harvest solar energy, and that's solar photovoltaics, PV, which is much more well known, and then solar thermal technology to generate heat. And so here we're focusing on applications of solar thermal for industrial heating. And currently, solar thermal technologies account for less than 1% of global heat demand. There are two main categories of solar thermal technologies pictured here. There's non-concentrating solar thermal and concentrating solar thermal, and the primary difference is the temperatures that they can achieve, with non-concentrating solar thermal providing heat up to around 100, 120 degrees Celsius, and concentrating solar thermal potentially going much higher. And we're primarily focusing on the former, the non-concentrating today. Next slide, please. And so here's our technology snapshot for solar thermal, summarizing a number of its characteristics. We just want to emphasize that the largest potential advantage of solar thermal technologies is being a zero emissions heating technology using energy from the sun. And there are some other potential advantages, such as that once it's set up, fuel costs and energy security, taking advantage of locally available solar resources. However, the key challenge for solar thermal technologies is that it's less suitable for producing steam for industrial applications, and it commonly only produces hot water for industries. And so textile processes often require steam to deliver heat, as well as maintain temperatures at a certain level. And so producing steam in the temperature range needed for the textile industry requires a significant amount of energy. And so for a thermal technology, 90% of the energy used to produce steam is just from turning water into steam, the vaporization, whereas only 10% is used for heating water. So if you're applying solar thermal, there aren't actually that many potential efficiency gains from just producing hot water. And so relative to some of the other technologies that we're profiling, solar thermal is not necessarily an effective way to reduce energy use and emissions in the textile industry, other than perhaps some case applications. Next slide, please. And so we also did our country readiness assessment for solar thermal technologies, looking at its readiness across the 20 major textile producing countries that we analyzed. In this case, the readiness score was based on a composite of indicators, including solar irradiation and solar resources generally available at the country level, the carbon intensity of fuel used in the textile sector. For example, those countries with the highest carbon intensity can lead to the greatest emissions reductions by switching. We also looked at climate policy ambition level and the general regulatory frameworks to support these low carbon technologies, solar technologies, as well as general availability. And again, we sorted them into the buckets of most ready, moderately ready, less ready without support. And you can see some of the most ready countries here, such as China, India, Italy, Morocco, Spain, etc. They have abundant solar resources and strong policy frameworks, and major potential benefits from switching. And I'll pause there. Actually, no, I'll turn it back to Ali for any further remarks on solar thermal and then moving into the next category of technologies.
Thanks, Cecilia. I think you covered everything. So solar thermal for industry, for textile industry, is rather is suitable for niche application. Like you could apply solar thermal, produce hot water, save some energy, but we are interested to get to net zero, deep decarbonization. For that, basically is not a suitable technology. Basically, it's not an option. Large scale solar thermal is just not suitable for, those are the ones that can generate the steam. They are not just suitable for textile plants. Plus, even that is very location specific. What we are talking about is decarbonizing the entire textile industry in China, in Bangladesh, in India, in Vietnam. So it's quite a niche technology with limited potential. So next, electrification of heating. So we have 3 technologies under this. I'm going to go through them. I have to be rather quick, being mindful of time. But let's talk about electric boilers. So electric boilers, they have been around for decades. They're not new. You can go buy them today. You could buy them 10 years ago. One thing to keep in mind, one myth out there that people have been asking and I've been answering over and over, people think electric boilers are for small scale, residential, commercial, and it's not suitable for industry. That is simply inaccurate. Like we have electric boilers that are suitable for massive chemical industry, even forget about textile industry. For textile industry is more than enough in terms of size. There are 2 types of boiler. One is electric resistant boiler up to 5 megawatt. Even that is already enough for textile industry. You can just put 2-3 of them depending on your load. And then you can have significantly larger electric boilers. They're called electrode boilers. And there are different technologies. And they have been a commercial also for a long time. So the conventional boilers, the steam boilers that are combustion boilers, they typically have efficiency of 70 to 80%, depending on various like fuel conditions and etc. But electric boilers, they can give you basically 99% efficiency. So they're very efficient, and that saving that will help. They have been commercial for a long time. If you install electric boiler and tie that with renewable electricity supply, if it's 100% renewable, then there you go net zero immediately. But even if you don't need to have zero carbon electricity in order to get your CO2 emission reduction benefit compared to fossil fuel, either coal or natural gas, there is a threshold depending on technology. For example, with electric boiler, if you have a electricity supply with CO2 emission factor of, let's say, 200, 250 kilograms CO2 per megawatt, then you are set. You will have lower emissions to generate the steam compared to coal boiler. So you don't have to be zero. Keep that in mind. One challenge for electric boilers are, even if it gives us significant saving, but electricity is higher grade energy form, so it's significantly more expensive per gigajoule per unit of energy compared to, let's say, coal or fossil fuel. And for a steam boiler, over 95% of boiler lifetime cost, including all the costs, is energy cost. So all you need to care about is the energy cost. And electricity being more expensive in most markets makes this technology challenging to adopt. I think I'm talking about some of these. So the strength, high efficiency, tied to renewable can give you low carbon. The challenge is high electricity cost. Actually, one other thing, which is the strength, the capital cost of electric boiler is significantly lower than a coal boiler. But again, the capex is not an issue when it comes to boiler. Most 95% of lifetime cost is the OpEx, the energy cost. So that's what we need to focus on. And for electric boiler financing, you need to look into kind of an OpEx financing, which is another challenge. Most of the financing scheme out there are CapEx financing for capital costs. But again, electric boiler is cheaper than conventional boiler, so you don't really need much CapEx financing. You need something to cover the additional operation, electricity, energy cost that comes with it. I'm going quick just to give you a snapshot. We have like around 10 pages for each of these technology in the report, so you can find much more in the report about these technologies. So next is the heat pump. Very interesting heat pump technology. The heat pumps are extremely efficient technologies, and they don't generate heat. They basically move heat. How they work, they get the heat from a heat source at certain temperature, and then they use electricity to lift from this heat source to what we call heat sink at a higher temperature. And because they're basically moving heat, they can be extremely efficient. The efficiency of them, they are measured with something called coefficient of performance. You can have heat pump, industrial heat pump, that have COP of like 6, 5, or even 7. That is like 500, 600% efficiency. Those are when you have lower temperature heat pump and a small, like 10, 20 degree maybe heat lift. For what we are interested in, for textile industry, a steam generating heat pump, high temperature heat pump. And for that, usually use the waste heat, usually available at 50 to 60 degrees C at textile industry. And then you lift it to a steam of, let's say, 120 to 150 degrees C. And because the lift is significant, then your COP will be around 2, 2.5, which is still significant. That's 200% efficiency, so to speak. And because they have this extreme energy efficiency that they give us, it significantly helps to reduce the operational cost, energy cost, compared to conventional boilers. But the challenge is heat pumps are CapEx intensive. They are costlier. So for heat pump financing, you need to look for the CapEx financing. By the way, they are commercial. You can go buy steam generating heat pumps, many suppliers already, but not in every single country. Mainly in Europe, US, Japan, and some other countries. In China and India, as we speak, they are developing more and more high temperature heat pump. I think I already spoke about these challenges and the strength of this. Once you have the heat pump, because of this significant efficiency gain that you have, then you can have electricity supply with even higher CO2 emission factor, because it uses significantly lower amount of energy, it will give you a still emission reduction compared to the, let's say, coal boiler. So that's another advantage that heat pump gives you. You can use, let's say, dirtier electricity and still get lower CO2 emission. But again, the biggest challenge here is the capex. The next electrification technology is the thermal energy storage, basically heat batteries. So there are different types of thermal energy storage systems. The most common one is sensible heat storage, but we have latent heat storage and thermochemical storage. But the sensible heat storage, basically what they do, they get the renewable electricity. I mean, that's the whole intention. They store it in a certain medium. This graph showing here actually is a commercial thermal energy storage system being sold by Rondo, is a US company. And they're using bricks, the refractory bricks, to store the heat. And they use electric elements, generate heat, store in this brick, and then throughout the day, you can literally just blow air, and then hot air comes out, and you can basically generate a steam from it. The system can be even one package. So they are most suitable to use low-cost renewable. In certain market, you know, we have renewable curtailment. You can even get negative cost renewable. Store it cheaply, and then throughout the day, you use this energy heat that is stored in your process for steam generation in very straightforward for the textile industry. There are commercial, significant number of companies have come up in the past 5 years. They are installing this as we speak. We have talked to a number of them. So they are not like upcoming technologies. They are, as we speak, done installing this. The capex is high, but like any other energy storage system, the capex are dropping fast. These thermal energy storage technologies are most suitable in geographies or countries or location countries where you have corporate renewable procurement market or renewable procurement market that you can take advantage of off-time, off-peak, or I should say off-peak, not off-time, off-peak, very low price renewable. Even though you have higher capex, because significant portion of this steam generation is the OPEX, the energy cost. So if you can really take advantage of off-peak, low-cost renewable, which it's not available in every market, but certain market it is available, then you go use this technology to take advantage of it. It is able to store heat at, let's say, off-peak, and then give you heat throughout the day with the demand you have, and that will be the renewable heat. So you can install a system that, you know, take renewable electricity at just a few hours during the day, 5-6 hours, and then give you the heat in 24 hours. The investment cost is high. Currently, it's dropping. It's a relatively new technology. I would say many of the textile companies or suppliers, they don't even know or consider these. We actually work with a textile company in Thailand. They were considering this. And of course, it does require renewable electricity supply, and in certain market, it may not be readily available. And the capex is a challenge for sure. So that was very brief introduction, really very brief about some of these electrification technologies. And then, like what Cecilia presented, we wanted to look at the readiness of countries for the overall electrification of heating, not just for one technology. We looked at number of criteria. This is not the readiness for electrification. This is just a PPA, power purchase agreement, in different countries that are ranked based on the PPA index that was published. In some countries, many, of course, US, many European countries, but also a number of Asian countries, namely India and China, there is very advanced, versatile corporate renewable procurement, including PPA there. So textile companies will be able to go do PPA and procure renewable in order to use it either for the electricity supply or for the heat supply. So that's a good news. Some of the countries, Bangladesh, Cambodia, Indonesia, Pakistan, Sri Lanka, this is really lacking at the moment. Things are changing. They have all the plans, but at this very moment, they're definitely behind, and they do need more support in that regard. We looked at other options or indicators like the share of clean electricity in total electricity generations in different countries. In these 20 major textile producing countries like, Spain, Sri Lanka, Germany, Cambodia, Vietnam, they have some higher share, and then some of the countries, they have lower share. So looking at the range of these criteria, we came up with a kind of a weighted average to rank countries based on the readiness for electrification of heating in textile industry. The criteria are listed here, and you have detailed explanation and data for each of those in the report. So some of the countries, no surprise, some of the European countries and Germany, Spain, Italy, they have very advanced PPA and good renewable, in US as well. So they're most ready. Some of the countries, China, Egypt, India, Sri Lanka, Taiwan, Thailand, Vietnam, they're moderately ready. Some more, some less, but we put in moderate. And then some countries definitely would need more support. At this moment, they are less ready. But that does not mean that a given textile plant cannot electrify there. But for the entire textile industry there to transition, they would need more support and need to get more ready. That was very brief on electrification. I'm going to turn it back to Cecilia to talk about natural gas, and then we wrap this up. But natural gas, again, is not a low carbon technology. It's just lower carbon compared to coal, and that is even conditional. There is a big if, which is the upstream methane emission. So it's really not the option you want to take it lightly. Cecilia?
Thanks, Ali. So next slide, please. So natural gas boilers are used in many industries. They're commercialized, readily available, and their effectiveness is very dependent on where natural gas is available in different textile producing countries. So our graphs here are meant to show firstly, on the left, what are the top natural gas producing countries? And you'll see that many of the countries on this list are also not necessarily the top textile producing countries that we've been analyzing. And on the right, we show natural gas imports by Asian countries. And again, many of the top textile producing countries in Asia are highly, highly dependent on natural gas imports. So in addition to the challenges that Ali mentioned earlier in terms of the total emissions impact of natural gas based on leakage upstream, there's also a major challenge in terms of natural gas availability, especially in textile producing countries where dependence on imports can lead to issues with supply, fluctuating prices, and so on. Next slide, please. So I think we've talked about natural gas a fair amount already, so I'll just recap. Some of the strengths and opportunities are that it's an established technology. In terms of direct combustion, it is lower emissions than coal in terms of both air pollution as well as greenhouse gas emissions. But if you include the upstream impacts, that is the major challenge for adopting natural gas. It's not necessarily a lower carbon energy source when you take into account these upstream estimates. And those can vary a lot across countries based on their ability to detect and monitor leaks and mitigate those leaks. There's also challenges in cost and supply. As we've seen with the war in Ukraine, there's a lot of fluctuation in international markets and geopolitics, and there may be some complex logistics for transport and storage and so on. Next slide, please. So we did also do the readiness assessment across the top 20 countries, textile producing countries, for natural gas. This is not necessarily a recommendation to adopt, but just saying that based on a number of indicators, some of these countries score higher. For example, some have a higher share of natural gas in their total energy supply, potentially indicating local availability. We looked at how much they're dependent on imports, which again can be a major risk point. And we also looked at pipeline length in each country. Some countries really have no natural gas or very little natural gas pipelines. And at the facility level, if an individual textile facility is not connected to the natural gas grid, it's almost impossible for it to consider this as a lower carbon alternative. And so here we've ranked the most ready countries, moderately ready and less ready. Yeah, and I think we can move on to the next section.
Yes, I see
sorry,
we are,
Ellie.
sorry, I see we are running a little behind. By the way, we are happy to stay 5-10 minutes longer to answer more questions, but we are going to wrap up by technology readiness summary, like 2 more slides, then we will get to the questions. Cecilia?
So after doing our country readiness assessment, we also wanted to compare the technologies directly to each other. And so we developed this low carbon energy source and technology matrix, where we evaluated each energy and source technology on a number of indicators to allow comparison. So going across the columns here, we looked at CapEx, OpEx, energy costs, technological readiness, the market growth outlook, the thermal efficiency of the technology, its potential to reduce CO2 emissions, and its potential impact on other environmental risks. And so here, I really want to highlight that a bar with more dark blue indicates a score that the technology is most optimal in that category. So for example, we looked at sustainable biomass, and relative to other countries, you can see that its CO2 emissions reduction bar is full, is dark blue. That means that if it is sustainably sourced, it is most optimal in terms of being able to reduce CO2 emissions. Whereas on the very bottom, we have coal. It has a very low score for CO2 emissions reductions because in terms of direct combustion and life cycle emissions, it's the most carbon intensive source here. And so you can look at this table in more detail in the report, but I just want to highlight that across the indicators, in comparison, electric boilers and industrial heat pumps rank most highly in terms of the indicators, with many of the scores looking quite optimal in terms of their high market growth outlook, high efficiency, and emissions reduction potential when paired with renewable energy. The next couple of slides are just looking at this information in another way, so I think we can skip through in the interest of time, and I'll pass it to Ali for our final recommendations.
Thank you, Cecilia. I think we have already mentioned all the points that are listed here, but I want to wrap up by saying, we have all these 6 alternatives, and as you all know, decarbonizing heat is a challenge. Everybody is trying to figure out how to do it. And people talk about all these options, but some of these options really, they are not an option. Like talking about natural gas, if you like objectively looking at it, I mean, first of all, it's not available in most of these countries. Second, even if it's available, you can't ignore the methane emission. And then there you go, you might have emission even higher than coal. And we cannot lie to ourselves, right? Biomass, if it's too cheap, too easy, and many plants are just switching left and right, where are all this sustainable or biomass coming from? There is a big, big red flag there. Solar thermal technologically is just not the right fit for textile industry because of the reason we mentioned. It's just for hot water generation, can give you a little bit saving, but really for deep decarbonization. That leaves us with electrification. Not that we have any bias towards it, but it can be a real solution, but we are not saying it's easy. It's not supposed to be easy when you want to get to net zero. It's a real solution in some market where now we have renewable PPAs, corporate procurements available. You will see this happening as we speak. We are going to publish actually a case study for India, and we are working there. And now that we have PPA available, people are seriously looking into this. In China, look at what's happening in China. PPA is available, and now China is one of the fastest electrifying country with the dirty grid, but because PPA is available. So it's a solution. The supply of electricity in some countries are there, so the financing needs to be figured out. Depending on technology, some need CapEx financing, some need OpEx financing. And in certain countries in South Asia, Southeast Asia, where the renewable supply is not available, certainly, there needs to be a push for that, which I think some of the brands can help, but that's a kind of a broader thing. So with that, I would like to conclude way more information and much detail available on the website in the report. So feel free to dive deeper there, and hopefully you'll find the information useful. And then in the next report that we'll publish, you will see the numbers in terms of potential CO2 emission reduction, cost for some of these key technologies in 5 major countries. And with that, I would like to hand it to Cecilia to perhaps moderate the Q&A, and we answer. I see there are a few questions. We can start. Please feel free to type your questions in the Q&A, and we will try to answer as many as we can.
Great. So actually all of the questions that we have so far are related to CapEx. So it sounds like the audience wants to hear more about CapEx, such as can we have the ballpark investment amount per technology, how per unit of capacity, how different are coal boilers and electric boilers in terms of the cost of energy per megawatt. That's a little different than CapEx. And then also, does the report provide an estimate of CapEx required for industrial heat pumps? So maybe I'll just briefly start. We didn't have time, but there is an image in the report that compares the steam generating technologies in terms of their relative CapEx. So we looked at a range of CapEx estimates for coal boilers, natural gas boilers, biomass boilers, electric boilers, and steam generating heat pumps. And you can see that in the report, but generally speaking, we found that electric boilers and gas boilers are 40 to 50% lower in terms of capital cost than new coal-fired boilers, whereas biomass boilers are somewhat higher, 20 to 40% higher, and heat pumps can be much more expensive. But it's very important to note that capital costs can vary depending on availability in different markets. In some places, electric boilers, maybe coal and electric boilers, for example, may be very inexpensive relative to other places. And I think maybe Ali, you can talk about further on the CapEx and especially on the heat pumps.
Yeah, the quick answer is we will give way more data, information, analysis on the CapEx in the second report that will be published in 2 months or so in November. And that was from beginning the plan that the second report will have numbers, we'll have analysis. This was more like a, broader assessment and of the scope of these technologies. But I guess Cecilia mentioned we have some information on the relative CapEx of these technologies. So I will leave it to that. Because CapEx can change by the size, by the country, and also in the next report, we will give more information on CapEx. I think
Great. Yeah, so we have a few other questions. One of the questions, are you considering to extend this analysis to other countries, for example, in Central and South America?
We could, in terms of this type of readiness analysis, we are not planning, but if we get the support, we are happy to do that. But I think more interestingly, the next report type of analysis where we develop detailed roadmap with numbers for each of the technologies, for a typical plan in those 5 countries, I would like to expand that 5 countries perhaps for more textile producing countries. I think that would be more practical, actionable type of information. But as of now, the plan for this report was these 20, and then for the next one is the 5 countries we are covering.
We have another question about energy costs. I think this is a really important point. How different are coal boilers and electric boilers regarding the cost of energy?
Coal boiler and electric boiler, that's a good question. It can vary significantly depending on the cost of coal and cost of electricity. Actually, as we speak, we are doing some study for different countries, India, Vietnam, Indonesia, and all that. And we realized, for example, for India, PPAs in many parts of India are cheaper than the grid electricity, and the prices are dropping. So as we use more share of PPA, power purchase agreement, renewable procured, for a typical textile plant, it can significantly help with the economics of electrification, both for boiler and heat pump. So that's the electricity side of things. And of course, the price of coal in certain or fossil fuel in certain regions are higher, in certain regions are lower. In the US, we have very cheap natural gas. In Europe, it's completely opposite story. So it can vary a lot. Typically speaking, electric boiler has higher energy costs than the coal boiler or natural gas boiler, but the delta, the gap can vary significantly from place to place.
Great. And then another question, we looked into solar thermal. The person who recognizes is not necessarily great for industrial heating, but can we imagine a scenario where solar thermal might be the best option? For example, in areas with good irradiance, like Arizona, you might be better off using electrification because PV would also be cheap. So could there be thermal storage, paired with solar thermal systems, I think, and so some of these other options around solar technologies.
Yeah, that's a good question. Again, we are not saying solar thermal is bad. It for a niche application might be the right application. If you have a plant that for some reason you don't need a steam, you mainly need hot water at 100 degree, 90 degree or so, then solar thermal is the way to go. But once you get into a steam, in this like smaller scale solar thermal, which is usually suitable for industrial plant, because larger scales are for power generation, you need a lot of land in very suitable condition. But a typical industrial scale, commercial scale that are usually smaller than those are the one, by the way, you hear left and right in the news that they are being installed. Those are usually for hot water. You can't go really for the amount of steam we are talking for a typical plant. But again, for a niche application, for a certain process you have where you don't need a steam, you just need some hot water, it could be good. But even for that, you should look into whether that's the best use of your capex or better to install, electrified system, whether electric boiler or electric heating. By the way, there is another type of electrification, which in the previous report we published, we covered, and that is direct electrification of process. Let's say you have a machine let's say a stentor machine for heat setting in a textile plant. Today, you can go buy a stentor machine that instead of using hot oil boiler or direct fire system, uses electric coils and electric heating. You can buy it today. Feel free to email me. I will send you the manufacturer. So German manufacturer, I think number of them. So there is that, but that we didn't include this because that tends to be, you have to change the machine in the process, more invasive to the process. So we left that aside. We went to the boiler room. We said, okay, just switching the boiler, don't touch the processes and machinery, and you just, electrify your steam generation. But again, in certain niche application or situation, or for a new plant, you can go with these alternatives as well.
Great. And we'll just take a couple more quick questions that we haven't gotten to yet. So one question was, did we do on-site energy surveys to characterize thermal energy use on site? Maybe the fuel is being used for power generation. I'll just give a quick response. This was not a site-specific study, but the next phase coming up, we will be getting to a more granular level about how energy for heating is used. And we would not be considering fuel for power generation, only looking at energy for heating. So the scope is clear. And then, yeah, sorry, go ahead, Ollie.
I can add to that for this next report, but also what we have been doing. We have received data from tens of different textile plants, thanks to some of the brands we have been working with. During the previous study we published 2 years ago, we got data from 40 different textile plants in China, Taiwan, Japan. In the last 2 years, we have been working with a number of textile brands and their suppliers in Vietnam, in Thailand, in Indonesia, in Sri Lanka, in India. So altogether, we have a good number of plants and their data, and we are using those in our analysis to characterize a typical textile plant with wet processing.
Great. And just last question, so we can wrap up at 10 minutes past. Would the higher heat pump capex compared to the alternatives be alleviated by the smaller heating capacity needed because of the higher coefficient of performance for heat pumps?
To some extent, yes. We are gonna again do that math in the next report. You will see the options and you will see like electric boiler. Let's say if you look at the bar, there is like this much capex and like big part opex. For heat pump is like significant part capex and smaller part opex. If you put the bars next to each other, how they compare, that would be the next report. But you are right that significant efficiency gain will definitely help us in terms of helping with cost effectiveness. But also one thing to keep in mind, the capex for industrial heat pump will significantly drop in the coming years. It still is like a new commercial technology. More suppliers are coming. I talked to this, again, industrial heat pump manufacturer, high temperature heat pump manufacturer in India. They were saying their heat pump capex compared to the Western heat pump for high temperature is half to 1/3 of a cost. And that makes sense because they're using local labor, local IP, and local components. And more importantly, when I talked to the European and American heat pump manufacturer, they said there's almost a 2-year wait. If you order tomorrow, they will install it 2 years from now, making it operational. In India, they were telling me like 2 months they can deliver. So what I'm trying to say, there'll be more supply, there'll be more competition, the prices will come down. I think with that, perhaps we can wrap up, Cecilia, right? Okay, great. But thank you so much, everyone, for attending and staying with us 10 minutes after the hour. Sorry we went over time. You see, we have a lot to present and it's an interesting kind of topic. Please look at our report. If you are interested, if you have questions, feel free to email us, or if you like to collaborate in this area, we would be happy to talk and discuss. But thank you so much and have a nice day.